Hi everyone, welcome back to my YouTube channel. So in today's video, we'll be solving Subarray Sum Equals K problem statements. It's a very popular interview problem. Okay, like always, we'll be starting with the brute force approach. Then we'll be moving to make our intuition more better than that, and then we'll be giving the most optimized approach. Okay, so this video is for anyone who wants to understand why this the particular solution that I'll be doing will work, not just memorize it. Okay, so I'll be taking it slow, but yeah, we'll try to explain everything. Okay, let's start with the problem statement. Now, given an array of integer nums and an integer k, return the total number of subarrays whose sum is equals to k. A subarray is a contiguous non-empty sequence of elements within an array. Okay. Now, if this question is asked to you during your interview, you should, understand what are the expectations of the interviewer from you, right? So if this question have been asked to me during one of my interviews, I would have cleared few of my doubts beforehand, right? So to check some things like what are the numbers that I'm dealing with, right? Are they positive or are they negative, or can there be zeros? Okay. Next is the value of k that I'm dealing with. Is it positive or can it be negative or can it be zero, right? One more thing that I want to ask would have been like, if the value of k, the sum that we are asked, does it exist in an array or not? Like, is there any subarray that whose sum is equal to k or not? Because there can be times when they give you random k, but it does not reside in your subarray, right? In that case, what I'm supposed to return, right? And the last question of all will be, what are the limitations of this array? Like, what are the limits? How many elements will be there in this array, right? So this is kind of a very novice question to ask, because you know uh, if someone is asking you a problem statement, they want optimized solution, and you don't need to worry yourself with if there will be 100 elements or 200 elements or 10,000 elements or 1 lakh or 10 lakh elements. You need to know that you need to provide the optimized approach, because in production level, in real life, there are millions of parameters, right? You need to make sure of that you are writing a code for millions parameter rather than 100. But it's a good thing to ask, ask the clarifying question, like, there's no harm in it. Okay, so let's start with what the question is asking again. So we have a nums array. We need to find the sub array inside of it, which has sum equal to k. Okay, so whatever sub array I get, whose sum, like the sum of whose element will be equal to k, is our sub array that we need to return. So basically we need to return the count of those sub arrays. So if there are 4 sub arrays with some k, then we need to return 4 as a count, right? So let's start with the solution now. When you have done your entire clarification, like you have asked your doubts, you have asked your expectation from the interviewer, then we move ahead with this problem statement. Okay, now providing the solution for the problem statement. Now I want you to pause the video for a minute and try to think, what steps should we do? Okay, so I always say that we need to divide the problem into sub problems, right? So first of all, the first sub problem here is that we need to find all the sub arrays. Okay, the second sub problem here will be, what are the which sub arrays have the sum that is equal to k. Okay, and the third sub problem is, what is the count of them. Okay, so I would like you to pause this video and try to find how you can find all the sub arrays. Okay, so if you thought of for loops, then you are in the right track. Okay, now I'll write a code that will give you all the sub arrays. Okay, so this will be the code for that. Okay, so what I'm doing here is, I have one outer loop, okay, that will be iterating one time on each element, and then I have the inner loop which will iterate over the entire array starting from the index I, which will go till the nth index, like last of the element. Okay, because n here is the length of nums. So what it will do is when I do the print nums of I to j, it will first print me 1, then 1 1, then 1 1 1. Now my outer loop will be in first index, then it will print me 1, then again 1 1, then when it is done, like this loop will be completed, then it will move to the second index and it will just return me 1. But here you will notice one thing, we will also get empty arrays. Okay, I want you to pause this video and try to find out why. Okay, what is the bug inside of it that it will also return the empty arrays. Okay, I will not be solving it because it's not the part of the problem right now. Okay, now we are done with this. Okay, we have found all the subarrays. Now what I need to do is I need to find the sum of the subarrays right now. Okay, so basically if I am doing nums of I to j plus 1, okay, if sum of temp is equals to k, then I will increase my count by 1 and then I will return a count. So what count will do, it will store the number of subarrays. Okay, if I run it, all the test cases are passed. So these are the demo test case. I will not be submitting the problem statement right now because it will be a waste of time, because this is a brute force approach and not an optimal approach. Now tell me what will be the time complexity of this solution. Time complexity as well as space complexity. Okay, pause this video and think of it. Okay, so if you thought that time complexity is big of n square and space complexity is big of 1, then you are little bit wrong here. Okay, so time complexity is correct because you are iterating on the loop 2 times. Okay, but not the space complexity. In the temp variable, we are storing our sliced array, basically the subarrays, right? So these subarrays in the worst case will take the entire array, right? When you are at 0th index and your jth is at nth index, then it means it is taking this entire array. Okay, so big of n will be the space complexity. Okay, now how can we optimize it? So if you see here, we are finding all the subarrays and then adding them and then increasing the count if the sum is equal to k. Okay, now just pause for a minute and think of a way that you can optimize it, that you can find the current sum of the array, like your index is at some position, okay, and you are able to find the sum till that position. Okay, try to think of that way. Okay, so if you thought of prefix sum, then you are on the right track. Okay, so what we will do is we will have one additional variable, let's call it s right now, which will store the current sum. Okay, now current sum will be s plus equals to nums of I. So what will we do with the current sum, right? The current sum will be increasing, not decreasing, right? But is there a way, okay, is there a way that we are able to find the part of the sum that it could have been without the previous elements? So what I mean is till this point, till the second index, our prefix sum will be 3. But is there a way to find out what will be the sum if this element was not there? Is there a way? Like, think of it. Okay, let's pause the video for a minute. By that time I will write something over here and we can then discuss over it. Okay, so I have written this something. So if you thought of hashmap, then you were correct. So now if you see here, I have taken the example of array 1, 2 and 3. Now if you see that at 0th index our sum is 1 according to the prefix sum, okay, and the difference is 2. Okay, fine, 3 minus 1 is equals to 2 because we have taken the second input. Now at first index our sum will be 3 and we see the difference is 0. Okay, fine, we found one subarray, 1, 2, 3. Now for the second index we see our sum becomes 6, okay, and the difference here is 3. Now, if you remember, I asked you earlier, like, is there a way that we can find a sum of a particular index by removing the sum till some of the elements of previous index? So if I want to find the sum of only this index without including these, how can I do that? So it's safe to assume that I can do current sum minus sum till previous index. Okay. Are you there with me till yet? Okay. So if I'm doing that, if I'm subtracting the current sum by the sum that I've already gotten, okay, and is there a way that I can claim that the sum is equals to k? Right, there is a way. Now over it, if you can see, my sum is 6, right? What is the difference with the k for it? It will be 3. Now can I find an already existing prefix sum that had sum equals to 3, that accounted to 3? Okay, yes, there was, which was here, sum was 3, right? So if I subtract this with this, my difference comes as 3. So that means I have another subarray whose sum will be equals to 3, correct? Because this is basically our the sum that we are wanting, right? So don't think of it in this way. Think of it way like you are subtracting, you are subtracting the current sum with the already existing sum, but somehow that the new sum that you got after subtracting these two is equals to k, right? Now with the difference here will be s minus k. S means sum. Okay, so I'll just do sum minus k. So whatever the difference comes up, if it is already existing in your subarray, right, if it is already existing with you, okay, during your prefix sum iteration, then that means these two particular part are is also subarray, right? So if this is your subarray till this point and till this point, if the difference is equal to the sum of this point, then we can also say that this is also subarray, correct? Because the difference we are calculating is from sum minus k. Now pause the video and try to think of a way to write this. Like, how will you be expressing it? Will you be storing your sum in your hash map, or will you be storing your difference in your hash map? Like, what will you be doing? Okay, so if you thought of storing your sum and comparing the difference, then you are on the right track. Okay, so how you will doing this? You will initialize the dictionary, okay, and then what you will do, I'll just comment it out. What you will do is you will check if your sum minus k is in hm. If it is, then you will increase the count by whatever the value is in your hm. Else you will just increment the value of your sum by plus equals to 1, and then you will return count. So you might be thinking why I incremented by hm of s minus k instead of 1. So think of a way, like if there was already some more existing sum, which like due to some point of time this 3 comes up multiple times, right? And then 6 comes up again and its difference is 3. So we need to make sure, so what I'm trying to say here is, what if this 3 comes up again, so just I don't want you to forget about this. So what if this comes up and then you suddenly get a 6 here, right? So for this particular point, till this particular point, you will have one subarray, you will have then two subarray, and then you will have 3 subarrays that will account to subarray sum of 3. Okay, so that's why we are incrementing this subarray one by one. Okay, whenever you get this sum, we are incrementing the sum in your hash map by 1, so that whenever you get another like another iteration where the difference is equal to the already existing sum, then you can increment all the previous 3 values in one go. Okay, I hope you understood it. Okay, now I think we are done with this. And okay, there is still one issue here which I will talk about in a few minutes. Sorry, few seconds. So yeah, the running finished, like the program ran, and you can see that there is an error. So why is there error? Like check this and try to figure out why this error was there. Okay. So tell me this, are you taking account of this zero, the zero difference that is coming up? No, right? So what you can do is you can initialize your hash map with the value 0 and which will be equal to 1. Why 1? So try to take it as 0, okay, and then dry run it when the code comes here. You will understand why 1. So let me explain. So whenever you are increasing the count, if your hm of s minus k, which is that like difference, if 0 is already existing and if you keep it as 0, then this will be incremented by 0. Okay, to try it, let's run this. Okay, I ran the code. And you can see the test cases failed again. So why does it fail? Why did it fail? Because we have incremented the value of 0 as 0, and after the sum is coming, like only then we are not even incrementing the 0 actually. But yeah, so 0 will be initialized as 1, so that whenever this count picks up, the difference picks up, it takes 1 for the first iteration and then keeps on increasing it again if it comes as a sum again. So there's a chances of sum coming in as 0 if you have positive and negative numbers simultaneously. Okay, so like if the sum comes till 5 and then next element is -5, so the sum will be 0, so you have to increment it by 0 again. Okay, now if I run this, so the test cases now have cleared. Now if I submit the code, so you can see my code has cleared. The runtime is 51 ms. So yeah, I think it's fine for Python. Okay, but it could have been better according to this. So that's up to it. I'm not worrying about it right now. So if you see, because my time complexity and space complexity are still what it is required as for an optimal approach. Okay, so my time complexity here will be big of n, okay, because I'm only using one loop, and the space complexity will be big of n as well in a worst case scenario because I'm using a hash map. Okay, so yeah, that's it for the video. I hope you enjoyed it. So for more such videos, please subscribe to my YouTube channel, and I'll keep on bringing such videos for all of you. I hope they are helping you guys, and yeah, thank you. Good night. Bye.